Good morning to everyone. I am Mr. Rathina Kumar, JTET, Bhubaneswar, Training Associate in Physics. Today we are going to discuss about the electromagnetic waves part 1. The learning objectives are, at the end of the session, students will be able to understand, describe, define and explain the given learning units. The learning units are: number 1, Hertz experiment. It is a production of the electromagnetic waves. And second, electromagnetic waves are transverse in nature. And third one, electromagnetic waves properties. And fourth one, electromagnetic wave equations. And then type of radiation and their frequency and wavelength range. Here in this first diagram, given the propagation of an electromagnetic wave. So this is nothing but the shown here in the diagram, a discharge of a spark or oscillating molecule dipole. This is the electromagnetic waves representation. Z direction, along with that, and here B is magnetic field, then symbol for E is electric field. Both are perpendicular each other, and the wave is traveling perpendicular to both of electric and magnetic field. Let us see this in described manner in the next slides. Electromagnetic waves introduction. Wave is nothing but a pattern of disturbance which propagates and carry energy with it. Actually, what is the wave means? It is nothing but a disturbance in the medium. That is called a wave. You can produce a wave on a rope by moving one end of the rope up and down. The wave produces on rope needs a medium to propagate, and here medium is rope itself. This type of wave is known as mechanical wave. But in the case of electromagnetic waves, they don't need a medium to propagate. Or we can say that electromagnetic waves are nothing but changing magnetic and electric fields. Electromagnetic waves are known as to be the solution of the Maxwell's equations, and Maxwell equations are the fundamental equations of the waves. That is electromagnetic waves. It can transmit energy and travel through a vacuum. Light waves are example of the electromagnetic waves. Generally, electromagnetic waves are shown by sinusoidal graph. Here the diagram A, B and A given. This is that wireless communication, or the transmitter and receiver in case of the electromagnetic waves propagation. And cell phone also one of the equipments or device to receive and transmit the electromagnetic waves. And this is the picture of this Xerox or this X-ray of the human body. This is also the application of the electromagnetic waves only. Light itself is called electromagnetic waves. The principle of Hertz experiment. Hertz is the scientist who discovered about these electromagnetic waves in a short distance. And the diagram picture is the Hertz. The existence of electromagnetic waves was confirmed experimentally by Hertz in 1888. This experiment is based on the fact that An oscillating electric charge radiates electromagnetic waves. The energy of this wave is due to the kinetic energy of the oscillating charge. Actually, this is a actual picture of the Hertz experiment. A and B are the two plates, just like a capacitor. That is S1 and S2, a gap at the point edge, and these two leads are taken to be joined with the induction coil. Induction coil, nothing but it is a magnetic waves produced. When a current is passing through the induction coil, the induced EMF will be produced here, and that will be carried at the point S1 and S2. When it gets charged, then a charge will come over here in between S1 and S2, and that charge will get ionized, and it will make a spark, and that will move away. So here the detector, if the wave comes from here S1 S2 gap, then that will be detected at the point of the detector. Here also it will get a spark. Then we can identify that electromagnetic waves are produced. And this is a setup made by this Hertz. Number one, induction coil produces high voltage. This is the coil. And second one, spark produces electromagnetic waves. And third one, electromagnetic waves create electric current in reasonable, produces small spark in the spark gap in this S1 S2, in between these two. So this is the diagrammatic representation. This is the experimental setup made by the Hertz. The constructions are shown here. It consists of two metal plates A and B placed at a distance 6 centimeter. So these plates are kept 60 centimeter from each other. The metal plates are connected to polished metal spheres S1 and S2. So why it has been kept as a two polished metal sphere means, this is the made up of the thick copper wires. Using an induction coil, a high potential difference is applied across the small gap between the spheres. So these spheres S1 and S2 are joined with the induction coil, which can produce high voltage. Then the charge will get charged, and charge will be discharged at the pointed spheres of this S1 and S2. So in that working, due to high potential difference across S1 and S2, the air in the small gap between the spheres get ionized and provide a path for the discharge of the plates. A spark is produced between S1 and S2. As I told, electromagnetic waves of high frequency are radiated. Hertz was able to produce electromagnetic waves of frequency about 5 into 10 to the power of 7 Hertz. Here the plates A1 and B act as a capacitor having a small capacitance value C, and the connecting wires provided low inductance L. So the high frequency produced or oscillating charges between the plate is given by the equation V is the new frequency. Symbol for the new frequency is equal to 1 by 2 pi root of LC, where L is the inductance and C the capacitor. So the plate A and B altogether called capacitor. The value of capacitor is substituting, and the value of inductance is substituting, then you can find the frequency of the magnetic wave produced in this experiment. The next, electromagnetic waves. This is the diagram representing the electromagnetic waves. See, that is a source. Source means the oscillating charge only is a source for producing the magnetic waves as per the Hertz experiment. And here notice that electric field, magnetic field, and is the direction of the wave propagation. And the wavelength, amplitude. Let's see first of all electric field. So electric field, this is represented in this crust upper portion, that is let us see, this is a y-axis, and the magnetic field in the x-axis, and the propagation is in the z direction. Actually, but the oscillating charge produces, when it's moving, the electric field produces. Along with that, when the charge moves, the magnetic field also produces. So both joined together is moving or perpendicular to each other in the direction of the z. So the amplitude is there, the maximum displacement of the wave is called amplitude. And wavelength is the distance between the one crust to the other crust or the one trough to the other trough. So in this diagram, we can conclude that, as shown in the figure, electromagnets consist of time varying electric and magnetic field, and they are perpendicular to each other, and these both fields are also perpendicular to the direction of propagation of the wave. And because of this, the electromagnetic waves are transverse in nature. Actually, the difference between the transverse nature and the longitudinal is that transverse means the waves are perpendicular to each other. So that property the electromagnetic wave has. That is why it is transverse in nature. Just like a ripple formation in the water surface. So these are all the example. Like that, the magnetic wave also obey these perpendicular each other, and the propagation of the wave is moving ahead in the direction of the z. Electromagnetic wave properties, or we can say the properties of the electromagnetic waves, and is a diagrammatic representation also given. The electromagnetic spectrum. Spectrum means the consist of all the radiations. We might have known already that visible spectrum, which consists of the VIBGR. So like that, the electromagnetic spectrum, they all come to the electromagnetic spectrum, and depending upon the frequency range and the wavelength range, and the electromagnetic properties are derived. Number one, these waves do not require a medium for propagation, and they are transverse in nature. This wave propagates through space with the speed of light in vacuum. So the electromagnetic wave has the speed at the speed of the light in vacuum. The wave has higher frequency, will have the higher energy associated with it. It can be used to carry information. It travels in a straight line. It can be reflected or refracted. When it gets refracted in the atmosphere, it produces the rainbow. And seventh point, it can be split and combined to form interference or diffraction pattern. So the light, when it is called light wave speed, it is naturally suffers reflection, refraction, interference, and diffraction patterns. So in this magnetic spectrum, as per this amplitude, wavelength range, is a radio wave, microwave, and then infrared radiation, visible spectrum, temperature of -6 centimeter, ultraviolet, temperature 4 centimeter, and X-rays, and then gamma rays. So these are the spectrum, are they according to the wavelength range. In case of the electromagnetic wave equation, one of the very important type of electromagnetic waves is sinusoidal plane waves. All electromagnetic waves can be considered as a linear superposition of sinusoidal plane wave traveling in an arbitrary direction. For example, a plane wave traveling in the x direction is of the form, and if E is the electric field is in the YZ plane, then in case of the electric field, we can take it as the voltage is here measuring as a voltage. So the EMF also we can say the E is equal to E naught. E naught be maximum, that is the amplitude of the electric field in case of here in the waveform. Sin omega t minus t by c, t minus x by c, where x is the distance, c is the velocity of the light, where E is electric field at position x t, electric field amplitude, angular frequency omega, and c is the speed of the omega is the angular frequency, c is the speed of the light in vacuum. Similarly, b is in the yz plane. So for that we can write the equation b is equal to b sin omega t minus x by c. So these are all, it has the meaning just like electric field here. B means magnetic field, and b naught is the maximum or the peak value of the magnetic field exists in the electromagnetic waves. Types of the electromagnetic wave and their applications. Depending on the range of frequency of the wave or various types of electromagnetic wave, and these waves have various applications in our daily to-day life. Following are some type of electromagnetic waves. Gamma rays, it is useful in detecting a fault or crack, flash, holes in a metal, that is a destruction of the metals, identification anything in the fault in the metal. And X-ray useful in X-ray therapy. Ultraviolet radiation helps in the study of molecular structure. Infrared waves helps for taking photographs in fog or smoke. Microwaves, these are used in radio and TV communication. And the electromagnetic wave equation, one of the very important type of the electromagnetic waves is sinusoidal plane wave. All electromagnetic waves can be considered as a linear superposition of the sinusoidal plane wave traveling in arbitrary direction. So just like the previous slide, the same thing, only there is no difference, the repeated one only. So in case of the electric field, E naught sin omega t x minus c here. In case of the magnetic field, B is equal to B naught sin omega t minus x by c. So these are called the two equations of the electromagnetic waves. Then here the table shows that the visible region, frequency and wavelength of the different type of radiation. Previous diagram we have seen that wavelength range. Here the infrared, the type of the radiation, frequency range and wavelength range. In case of the gamma, note here 400, 500, 600 and 700. Here the last one is ultraviolet. The first one is infrared. So if it is you can say that the red is the maximum and violet is the ultraviolet is the minimum. So type of radiation, gamma rays ranges, frequency ranges 10 power 20 to 10 power 24 and wavelength ranges less than 10 to the power minus 12 meter. And X-rays 10 power 17 to 10 power 20 frequency and 1 nanometer to 1 picometer. Ultraviolet 10 power 15 to 10 power 17, 100 nanometer to 1 nm. Visible 4 to 7.5 in 10 power 14, 750 nanometer to 400 nm. This full is called we can visible, that is means WebGR we can say that. And infrared 1 into 10 power 4 minus 4 into 10 power 14, 2.5 micrometer to 750 nanometer. And in case of infrared, frequency is 10 power 13 to 10 power 14 and wavelength range 25 micrometer to 2.5 micrometer. And microwaves 3 in 10 power 11 to 10 to the power 13 in frequency and 1 millimeter to 25 micrometer. 10 power 6 it means. Radio waves less than, it is a 3 into 10 power 11 and the wavelength range is 1 millimeter. Okay, now get into summary. Then we have what you have learned, otherwise, but recall that what you have learned. It is first one is the Hertz experiment. It gives the production of the EM waves, that oscillating waves. Oscillating charge only give you the magnetic waves. And the electromagnetic waves are transverse nature. That means when the, according to this diagram, you can remember the electric field and magnetic field both are perpendicular to each other with the direction of the propagation of the wave. And here itself the source which can produce the discharge of spark oscillating molecule dipole, which produces the electromagnetic waves in the form of spark. And you have studied about the electromagnetic wave properties. It moves in a straight line and moving with the velocity of the light. So these are the properties of the magnetic waves. And electromagnetic waves equations is equal to E naught sin omega t, and magnetic equation B is B naught sin omega t. Then type of radiations and their frequency and wavelength ranges. So these are all we have discussed today. Let's see the one simple question for your assignment, or take it as a note. Then explain Hertz experiment for EM wave production. List out the properties of the electromagnetic waves. Explain electromagnetic waves are transverse nature. Mention any 5 types of radiations with their frequency in ascending order. Such type of question will be asked. The fourth one will be often asked in the even board examinations. And these things you might have learned and you could be able to write, I hope that. And books for reference: H.C. Verma, Holiday Resnick, Survey and JVET Physics for Scientists and Engineers, David J. Griff's Introduction to Electrodynamics, Paul Tipper and Jean Mosher. These are all just for your reference, and most probably you can follow the NCERT textbook and SCERT textbook for more understanding in simple languages. This is the end of the electromagnetic wave part 1, and thank you for watching.